In this video, we're going to be looking at the exponential function and how we can graph it and what it looks like, and then using dilations, reflections, and translations, and how this affects the equation and what the graph looks like. So to begin, when we're talking about exponential functions, we're talking about functions such as y is equal to 2 to the x, where x is the index or the power form at the top. So this base number 2 can actually be any number, and it will be this standard shape. So it could be y is equal to e to the x, so that's quite a common one, but you could also have any other power. So the graph has a function that intercepts here at 0, 1. And that's because when x is equal to 0, any number to the power of 0 is equal to 1. So hence why that point there is 0, 1. So unless there's going to be some dilations, as we'll see later, typically this point will be 0, 1, and no matter what the base is, it's always going to be 0, 1. Then it's going to increase. It will increase at different amounts depending on what equation it is though. So for this, we'll look at y is equal to e to the x. That goes up like that, and then it comes down, and it gets smaller and smaller and smaller due to y is when it's e to the negative x is equal to 1 over e to the x. And it gets smaller and smaller, and then it approaches the x-axis, so it approaches 0. So that means there's going to be an asymptote. And that's quite important that you remember to put that asymptote in there at y is equal to 0. So draw that in, then draw in the line, y is equal to 0, and that's an asymptote. So that's the general shape of the graph. So you can see that there's not going to be any negative y values. We've discussed that before. And then it gets closer and closer. So there is an asymptote, that's a key feature. And then it's going to go up. And for any base, it's this general shape. But of course, the shape may change. So it may look like that or something slightly different. However, it still will intercept at the point 0, 1 in its base form. So looking at dilations. So what happens when it's from the x-axis? Well, you have the general shape of the graph here. So we'll say that's y is equal to e to the x. And then this is 0, 1. So we're going to dilate in the x-axis. So that means we're replacing y with y on k. As you remember, it's like the opposite. Then when you times it over, we're going to get y on k is equal to e to the x. So y is equal to k times e to the x. This means we'll get things such as here, where this is y is equal to, let's say, 4 e to the x. Now this point here is going to be 0, k. So this time it was 4, so it's going to be 0, 4. Then if it's a fraction, it will be lower, so it'll be down here. So it does, the main thing to note is that the asymptote doesn't change. So the asymptote is still here. And that's quite important. So the asymptote doesn't change when you're dilating from the x-axis. However, that y-intercept does. So looking at the dilations, what about from the y-axis? So that means we're replacing x with x on k. So now the equation is going to look something like y is equal to e to the x on k. So let's say k is equal to 2. Therefore, y is equal to e to the k on 2. Now, the general shape of the equation looks like that. So that's y is equal to e to the x. But then y is equal to e to the x on 2 is going to look like this. So that's y is equal to e to the k on 2. Obviously, the asymptote is still there. However, you'll note that this point here is still going to be 0, 1. So when you're dilating just from the y-axis, no matter what the dilation is, it will still go through this point here. And you can work out why is the purple line like this, y is equal to x on 2. Well, because when x increases, x on 2 will increase, but not as much as x. So if e to x was going to increase, then e to the x on 2 will increase, but less. So this is a big increase, but this one's going to be slightly smaller, and that's why you see that. So it definitely is increasing, but at any x point, y is equal to e to the x will be greater than this, apart from when it becomes negative. And the reason for this is because when it's negative, you have y is equal to e to negative x on 2, which is equal to 1 over e to the x on 2. So as x becomes more negative, it's 1 on, and therefore it becomes smaller. So this line should probably go down a bit more. It does get smaller, but the green will get smaller quicker because this bottom term is larger. And as 1 on bottom term, when it's larger, it's going to become a smaller fraction and therefore closer to 0. So what about reflections? Well, with the reflections, it's pretty standard. You have y is equal to e to the x. And let's say we're reflecting the x-axis. It's just going to look like this. Graphically, it's quite easy to see. And then when you reflect in so this is the x-axis, we're replacing y with negative y. So that means we're going to get y is equal to negative e to the x. And we can see why that's the case. That point there will become 0, 1, 2, 0, negative 1. So at the moment, the asymptote stays the same. However, this is not for all reflections, because if you have a graph that isn't the standard form and it's translated up, like for example, the asymptote is up here, then when it's reflected, the asymptote will go down here. It also will reflect. The only reason why it doesn't reflect is when you have asymptotes that are y equals 0 or x equals 0, no matter what reflection happens, it stays the same because it's on the axis. So it's like being on the edge of a mirror. It's not going to reflect because it's on the very edge, and whether it's the y is equal to 0 or x equals to 0, no matter if you're reflecting x or y, it will stay on those axes. But you have to note, if the asymptote isn't on those axes due to a translation, then it will reflect if you're reflecting after the translation. So what about if we now look at the y-axis? So that means we're replacing x with negative x. So we have the original equation here, y is equal to e to the x, but now it's just going to look like this. Y is equal to e to the negative x. And that's because we replace x with negative x there. This point here will also be 0, 1. And then it's just going to increase when x is negative and then decrease when x is going to 0. The asymptote will stay the same, so it will still be y is equal to 0. That's because even though it's not approaching at this point, like it was before, it is now approaching at a different point. And this when you graph there, that is technically not correct. But you really want to make sure that it looks like it's never increasing again, so it goes all the way straight down. Just a quick note with regards to the reflection in the x-axis. When you're talking about e to the x, one of the common things is it always has to be greater than 0. But once you reflect in the x-axis, you're going to get negative e to the x. So the thing to know is negative e to the x will always have to be less than 0. So for worded questions, this is sometimes useful, as it can tell us, depending on what the question is, but it could tell useful information. So finally, some translations. So what happens when there's a translation in the vertical? So we have this up here. You have the general equation y is equal to e to the x. So if we translate vertical, that's like the y. So we're replacing y with y minus k. Y minus k is equal to e to the x. Y is equal to e to the x plus k. So this is going to mean the asymptote changes to y is equal to k. And you should be able to see why that's the case, because as this approaches 0, when this approaches 0, then that means y will approach k. So we have the asymptote there, and then this line will go up. And if there are no changes, this point here will be 0, 1 plus k. The reason why it's 0, 1 plus k is because when x is equal to 0, you have y is equal to e to the 0 plus k, which will give you 1 plus k. So that's a translation in the vertical, and obviously you could go down as well. So instead you could have something that looks like this, which means that there's going to be an x and y intercept. So what about a horizontal translation? So that means now we're looking at x is being replaced with x minus k. So we're getting something that's like y is equal to e to the x minus k. So if originally we had this graph here, y is equal to e to the x, and then we change it to y is equal to e to the x minus 3, then we're going to find that at this point here, you'll have 3, 1, and then it will be exactly the same, but we've shifted over 3 across. So that means the asymptote has stayed the same. So there still is asymptote at y equals 0, but we've just shifted the graph across to the right, or we could shift it to the left. So it doesn't have as big of an impact as, let's say, the vertical translation, but you do have to note that the y-intercept will change, so when x is equal to 0, and then you also have a new point that whatever the shift is across, the y value, for example, if the shift is 3, then it'll be 3, 1, or generally it will be k, 1. And you can see that because when you have e to the k minus k, this will give you e to the 0, which is equal to 1.